Okay, so we're here with part 2. We're going to be continuing on with 10.1.2. With 10.1.2, we're going to have to prove that, two angles are equal to each other, but it is a bit different, guys. So just make sure you watch this video carefully, do it over and over again. And after this video, I'm going to show you exactly how easy it actually is. But other than that, let's continue. So now we already answered question 10.1.1. Let's go on to 10.1.2. And if you haven't watched, there's part one. I've already linked part one in the link in the description. If you've already missed that, just go back and watch that video. Let's continue on with 10.1.2. We have to prove that S equals to P2. Okay? So now now guys, when it comes to these type of Euclidean questions, I want you to write it down. We have to prove that P2 equals to S. Where do we start, guys? I always suggest to look at the position of both of the angles on your diagram. Where is S? Where is angle S? Angle S is over here. And we were not able to connect it to any angle through any Euclidean theorems. We weren't able to connect it through our cyclic quad theorems. We weren't able to connect it through tangent theorems. No, we haven't. We haven't been able to do any of that. So when we haven't been able to connect an angle directly to another angle using Euclidean theorems, guys, what do we think of? We think of exterior or sum of angles of a triangle. We think of writing it out, or using exterior angle of a triangle, sum of angles of a triangle. We think of angles on a straight line, and we think of vertically opposite angles. Okay, so those are the four geometry theorems I want you to think of. But let's look at P2 for a minute. P2, we were able to connect P2 to another angle. We were able to do that. We said P2, right? We said that P2 equals to T2. Okay. And we also said, yeah, so that's the only angle. We said that P2 equals to T2. And we also know that P2 is a part of a larger angle. It is a part of P1 plus P2, which equals 90 degrees. But let's just start off small. We don't want to confuse ourselves, right? So let's just start over here. P2 equals to T2. Where do we start? What do we do? The very first thing that I want you to do is I want you to start with angle S, because angle S isn't really directly connected to any angle using Euclidean theorems. I want you to write out angle S in an equation involving sum of angles of a triangle or exterior angle of a triangle. Let's start off with exterior angle of a triangle. But when you're using this theorem, please make sure that it includes either P1 or P2, because we're trying to link it to P1 or P2. If we look at P1 and P2, if you look very carefully, guys, P1 and P2 is actually at the exterior of the triangle that S is a part of. It's on a straight line. It's at the exterior. Okay, so we can clearly see that it's at the exterior. And we know that when it comes to exterior angle of a triangle, the exterior angle is going to equal to the opposite interior angles of that triangle. So the angles that is opposite from P1 plus P2 would be both S plus R1. Okay, so if you guys aren't really familiar with how to use exterior angle of a triangle, make sure you just go back over that super duper important information. So what you want to do is you just want to quickly go back and write down that S plus R1 equals to P1 plus P2 because of exterior angle of a triangle. Now what do we do, guys? Remember, we're trying to prove that S equals to P2. How do we do that? What I want you to do is I want you to write down a list of all the angles that R1 equals to, and write down a list of all the angles that P1 is equal to, so we can try and connect them to one another. Okay, this is what you do, guys. This is what you do. So what angle is R1 equal to? So just look at the green color. We've connected R1 to T1 plus T2. We can see they have the exact same color. Why was that? Because of exterior angle of a cyclic quad. So we already know that R1 equals to, I'm just going to label it as PTK. Okay, I'm going to label, you can just say T1 plus T2 if you, let me just say T1 plus T2. So we know it's equal to T1 plus T2. And now let's write down a list of all the angles that P1 equals to. P1 equals to, P1 also equals to, guys, just look at that. P1 is literally highlighted, it's annotated in pink. P1 also equals to T1 plus T2. We've already found an angle that they have in common, guys. So P1 equals to T1 plus T2 as well. And just like that, guys, we found an angle that they have in common. But now what do we do, guys? Remember what we're trying to prove. You need to remember this. We're trying to prove that S equals to P2. And we know that R1 and P1 are equal to each other already because they both have an angle that they have in common. They're both equal to T1 plus T2. So now that we've already proved that R1 equals to P1, we can change we can already change R1 as being equal to P1 because they're equal, right? So R1 is equal to P1 because they're both equal to T1 plus T2. So all we have to do, guys, P1 is going to cancel themselves out. Those two variables are going to cancel themselves out because when you take P1 over onto the other side, what's P1? P1 minus P1 is 0. So we know that the P1s literally cancel themselves out. They disappear. And by the way, guys, there are literally several ways of answering this question. This is the method they've used on the memo, by the way. Okay. So they cancel each other out. We had plus P1 over here. Okay. So once you take P1 over onto the other side, obviously it's just going to end up being 0. Okay, it's going to end up being 0. So then you're left with S1 equals to P2. Oh, not S1, sorry. S equals to P2. And just like that, we've already proved that they're equal to each other. It's literally that simple, guys. Just use this method. I want you guys to do this over and over and over again. But let's just quickly go over them and see exactly how they did this, okay? You need to get each and every single mark. So you're first going to do that exact same thing. First going to state the fact that R1 equals to PTK. PTK is literally just T1 plus T2, like I explained, because of exterior angle of a cyclic quad. And then you see the way I've drawn it, the way I've literally showed it and represented it through an equation was just to make it as easy as possible to, because sometimes when you look at a question, you don't know where to start. So you just need to use the visuals. You need to try and connect those two angles using an equation to see how you can manipulate that equation to, get to your answer. And that's exactly what I did because you don't really know about the fact that you're supposed to first connect these two angles. No, you don't know that. And that's exactly what I showed you in this video. But anyways, first state the fact that R1 equals to T1 plus T2 because of exterior angle of a cyclic quad. Then you're going to say that P1 equals to T1 plus T2. Remember, because of exterior opposite angles of a opposite angles equal sides. Remember, T1 plus T2 equals to P1 because of opposite angles equal sides. Okay, and then you're gonna draw that equation that I've showed you because of exterior angle of a triangle. S plus R1 equals to P1 plus P2, just like I've showed you. Remember, guys, we've already proved that R1 and P1 are equal to each other because they're both equal to T1 plus T2. Remember, I already told you that, T1 plus T2. And then what you're going to do is you're just going to change that to P1 because we know they're equal to each other. Take that over onto the other side. They cancel out, meaning that S is going to equal to P2. This is a very good question. Okay, very good question. It really helps you think up a lot of different things that we've learned throughout the year. Okay, guys, so I don't want to make this video too long, and just like I said, I really just want you to focus and concentrate on the information that I've given you through this video. Go over this question, guys. You're not going to improve if you don't go over the same question over and over again. Use this exact same method that I've showed you. You only use this specific method when you have an angle that you can't really connect to any other angles using your conventional Euclidean theorems. You're going to start picking up on this. You're going to start seeing a common thread amongst these questions the more you practice it, okay? I'm going to link part 3 in the video, part 3 of this video, where we're going to be finishing up with question 10.1.3 and 10.2. So make sure you go back over this question, watch it immediately as soon as you get the time. And just like I said previously, guys, if you really want that effective preparation, if you really want to go from that level 3 to that level 7 to level 6, level 5, level 7, whatever your goal is, then make sure you email me so that I can give you more information on the online sessions that I'm hosting. But other than that, I will see you in part 3. Make sure to watch it, and I'll see you in the next video.